Hey guys, this is Mr. Humbert here, getting ready to teach you how to do graphing linear inequalities, section 7.5. Some special notes for our notes. Number 1, sometimes you might have to rewrite the inequality so it's in slope-intercept form. I will show an example later to how you do this. The second thing, determine if your line is dashed or solid. So if you have a less than and greater than symbol without a bar, they're dashed. If you have a less than or equal to and greater than or equal to, they are solid. So when you see the little line underneath, you get a solid. So if there's not a line underneath, you're going to make it a dashed line, and if it's got a line underneath, you're going to make it solid. And the third thing is we're going to determine where we shade. The whole idea of this is shading. We're going to shade above or below with a test point, usually 0, 0, but any point would work. We like to use 0, 0 because we know where it's at. Remember, 0, 0 is the origin. Okay, let's move on to our first example. We're going to graph y is less than or equal to 2x minus 1. Okay, so first thing I want to do is write down the slope and the y-intercept. So the slope is 2 over 1. It's still the number in front of x, even if it's not an inequality symbol. And the y-intercept is negative 1, so b is negative 1. Remember, that means the ordered pair is 0, comma, negative 1. So what we're going to do is we'll go over to our graph here, and we're going to find negative 1. Let's see, I'll put a dot right there. And then from that dot, I'm going to go up 2 to the right 1. And I'm going to continue that process a couple of times. I can also go down 2 to the left 1. So as I noted above, we need to determine whether this is going to be a dashed or solid line. So quick recap. When we graphed x is greater than 5 on a number line, this is back in chapter 4, we put an open circle, we shaded to the right because it was everything above 5. Well, we had put an open circle because 5 wasn't part of the answer. Well, when there's a bar, we filled it in. So this will have a solid line. So when I graph my line, it's going to be solid. So do the best you can to keep it straight and go through those points. So my line's not perfect, but you guys have straight edges, so hopefully it's better. Now comes the shading. So shading is letting us know what points are part of the solution. So in order to do that, what we're going to do is we're going to plug in a test point, which I suggested earlier as 0, 0. So what I'm going to do is I'm going to take the 0, 0, 0, comma 0. I'm going to plug it in for x and y. So both y and x are going to be replaced by 0. So plug that in. 0 is less than 2 times 0 minus 1. So 0 is less than or equal to 0 minus 1. Is 0 smaller than negative 1? That is a false statement. So what that means is that up here where 0, 0 is, say I put a dot at 0, 0, that is not true. So all the points over here are not true. So I'm not going to use those. So let's erase that. I'm not going to use those points. It's going to be everything on the other side. So let me go ahead and highlight everything over here. So all the points on this side are solutions to this inequality. If I take any of these points and plug it into that inequality, it will make it true. So it's all these points, kind of like when you shade x is greater than 5 or x is greater than or equal to 5. All of these points are solutions. So I shade everything I can over here. So you can lightly shade with a pencil. Some people like to use highlighter, but you can't erase that if you make a mistake. So just be careful when you guys do your homework from that worksheet. Let's move on to our next example. Example 2. So example 2, same idea, different numbers. So we're going to use m again is negative 2/3. So remember, when we do negative 2/3, we want to write the negative on the top. Okay, and my b is positive 2. So I have negative 2/3 and a b of 2, so I'm going to start at 2. I'm going to go down 2 to the right 3. So down 2 to the right 3, down 2 to the right 3. I'm going to go ahead and put more dots on. We can also go up 2 to the left 3, up 2 to the left 3, and we've got dots. Now, this one's slightly different because it is strictly less than. So if you look over here at the inequality again, it is a less than symbol. There's no bar. So kind of like when we graph like x is greater than 5, we put an open circle, we're going to put a dashed line. So I have to put a dashed line. So I'm going to make this line dashed. So what I do is just make it so it's not connecting all the way. You guys can use a straight edge, just don't make it a solid line. Make it dashed. Okay, so this is a dashed line. Now we're going to shade. So to shade, we use our test point of 0, 0. Here's 0, 0. So 0 is less than negative 2/3 times 0 plus 2. Oh, look, 0 is less than negative. When we use 0, 0, negative 2/3 times 0 is 0. So when you plug in 0, it's nice because the fractions cancel out. Is 0 less than 2? That is true. So that is true. So this is true. This point right here is true. So what that means is everything below there is true. So that's where all the shading is. So since 0, 0 is on the true side, we shade 0, 0. In the last example, we didn't shade 0, 0 because it wasn't on the true side. So we're going to shade all of this down here. Now, another way that people like to do the shading rather than using a test point is to look at the inequality. So the inequality here, if you look at the inequality symbol, it is a less than, and we shaded below the line. Okay, if you go back up to the other example, that was a greater than, that was a less than as well, and we shaded below the line. So when you have a greater than, you would shade above the line. All right, let's look at our last example. Example 3, 2x minus 3y is less than 6. You will note that this line is not in slope-intercept form. So it doesn't look like y equals mx plus b. So we have to rewrite it. There's a couple of things we have to remember though. When we're rewriting this, we'll be moving the variables, and also we will have to remember that when we divide an inequality on both sides by a negative, we'll switch things around. So I'll do that when I start writing it down. So let's go ahead and do that. So this example, I want to make this look like y equals mx plus b, so I'm going to move the 2x. We've done this before. We're going to have negative 3y is less than negative 2x plus 6. And then we're going to divide everything by negative 3. So I've got y. Now, I divided everything by a negative, so this is a negative, this is a negative, negative. So we're going to switch the inequality around. It's greater than. And negative over negative is positive, so 2/3 x. And then 6 divided by negative 3 is negative 2. So y is greater than negative 2/3 x minus 2. All right, so when I go to graph this, I'm going to start at negative 2. And I'm going to go up 2 to the right 3. Up 2 to the right 3. Up 2 to the right 3. Down 2 to the left 3. Graph a couple of points. Down 1, 2 to the left 1, 2, 3. Now, since this one is a less than symbol with no bar, it's going to be dashed again. So I'm going to make a dashed line here. So make it dashed. And you've got yourself a dashed line. Now, we have to shade. I'm going to plug in 0, 0 into the original equation. So I'm going to put it back into this one. So I'm going to plug in 0, 0. So this one's easy. 2 times 0 minus 3 times 0 is less than 6. Now, why I put it in the original equation? Because we manipulated the equation, and if we forgot to switch the inequality, we would shade in the wrong place. So 0 minus 0 is less than 6. 0 is less than 6 is true. So here's 0, 0. It's less than 6. That's true. So we're going to shade above. So everything above gets shaded. So we're going to shade everything up above. This would continue on forever, but our graph only goes up to a certain place. So I would shade everything in here all these points would make this inequality true, and that would be our answer. So it's everything above. Now, notice that the original inequality has a less than, and we didn't shade below, did we? Because when we rewrote it, and we divided by a negative, we went to a greater than. So only when you solve the equation for y would you possibly have to switch the inequality around. You don't switch it around otherwise. So it doesn't change if you have it in slope-intercept form. Go back to our previous examples. I didn't have to change any inequalities because I wasn't rewriting it. I only have to redo that. So this one was greater than is above the line, but we use our test point to kind of double check that, and it's 0, 0 is less than 6. That is true. So that's why we shaded up here. Okay, go ahead and complete that worksheet, and good luck.